I may have misunderstood what Greta meant by normalization. We come from two different fields. So anyways, I'm going to try this. But first, I'm going to try a little light humor. I'm going to tell you two quick anecdotes. I was an avid curler for many years. And when I moved to Toronto, there was a fellow in my curling league who was a lead engineer for Don Ellis, the company that built the Skydome. And he was telling us after a couple of years after a curling match that in the early design stages, they built a scale model 4 feet long of the Skydome. And then when they went to test closing of the roof, all the gantries and all the lights sheared off because somebody had multiplied by 10 instead of dividing by 10 in their metric to imperial conversion. Of course, when it happens on a scale model, it cost $1,000. And if it had happened in real life, it would have been $500,000 or something. And then a second one was a situation I was presented with about 54 weeks ago, where a little database project that another consultant had come in and built suddenly wouldn't accept 2016 data, and they were starting to prepare the first drafts of this year's budget. So I went in and looked at the table, and it's a little access database. It's got 80 or 90 descriptive columns, and then it's got an opening balance and some summary values for 2010, 2011, and 2013. And then the next field is called O-Jan-13 for orders. Sales-Jan-13 through margin-December-2015. So I thought, okay, this is going to be painful, but I'm going to have to add, there's 13 times 4, so another 52 columns. Oh no, that brought the column count to 280. And there's a hard limit of 255 columns in an access database. So, turns out as I went through that he had actually done that the year before and pushed out to 15 rather than addressing the problem. So I had to go in and, so he's built this thing over about 7 months, and I had to spend another 10 weeks actually going right. But my point is, normalization is important, and in this case I'm talking normalization of data models, which probably is close enough to what you need to deal with occasionally anytime you're designing a database. And accurate models are valuable, which is the lesson of the first anecdote. So anyways, normalization myths debunked. Let's see how this goes. If everyone starts screaming, I'll stop. So I'm going to go through, there's a variety of reasons that are normally given. I like to think of these as mythic because they don't really address what's going on. We're going to talk about why normalization actually measures fidelity of the model. And then what does faithfulness or fidelity mean? And what's the significance of thinking about normalization of databases in this fashion rather than in the traditional one? So the usual reasons given for normalization are actually mythical or inaccurate. In a different crowd, I might ask for some guesses. No, we'll just do these. These are the typical 5. Reduces redundancy on the data. How many people actually have any sort of sense of what a database normalization is? A couple. Okay, I'm going to pause for a second. On the first half, when I had the activity-based costing example with all the accounts, that would be regarded as an unnormalized data structure because you would still have to store a 0 in that value even if it didn't exist for that row. Now it's just one example of a denormalization, but then when I pivoted it, if there was no value, you simply omit that row. And what that does is structurally require certain values, and it actually leads to the structural impossibility of some classes of funds. Hopefully that gives you a little bit more sense. If you've got questions, I'm here afterwards, and I can give you a little bit more background. But I didn't realize that we had this confusion on what normalization meant. Reduce the data volume, so this is good also. Simplify updates, that's clearly a good thing to do. Organizes the data structures, that's good. And it enforces data integrity, the point I just made. So all of these are good things, but they don't really address the fundamental reason of why database normalization is beneficial. And I call it mythical because it's just a laundry list. They're just side effects of the real reason, which I'll cover in a moment, of why full normalization should be the usual default design standard. There are occasionally reasons why it's valid to not normalize. Data warehouses are an example. Data warehouses are completely denormalized. And that gives them very fast response for the particular reports that they've been denormalized on. But they do everything else really slowly. It's a trade-off. But for a transactional database, you almost always want it fully normalized or very close. Also, when you think about it as this laundry list, it's too easily to be challenged, or too easy to be challenged when somebody says, oh no, we should denormalize this set of tables over here because it's going to give us better performance, or it's going to do whatever you say. And when it's this list, they can say, well, no, I'm actually going to do this better. And it's too hard to rebut that accurately. So I believe the real reason to normalize is normalization measures fidelity or faithfulness. So that's the definition from the web. Fidelity means faithfulness, or the degree of exactness with which something is copied or reproduced. So when we're building a model, when our model is faithful to the real world, and we got something wrong, we shear out the lights and it's cheap because we found out before we actually spent $1 million building this item. So faithful to what? The business requirements. The business requirements are the description of the real world as it applies to the application being built. The data structures themselves comprise a model of the real world as the analysts have captured it in the business requirements. So a faithful model of the business requirements will be as faithful to the real world as the business requirements are. This is in fact a type of unit test of the business requirements. If your data modeler goes through and he has questions, he goes back to the analyst might go, oh, it means this, or he might go, oh, I forgot about that. He goes back to the users. So when you make the data model accurate to the business requirements, you're actually exercising the business requirements at the early stage of the design. And that's a type of testing. So what does faithfulness mean? Well, a faithful model, and you'll see I've got some of these in green, and these are the laundry list items. But you'll see I've got other things here besides the laundry list of the common reasons to normalize. So a faithful model enforces the business requirements, and that's enforcing data integrity. A faithful model documents the business requirements, and that's organizing the data structures. A a faithful model maps more accurately and precisely to other faithful models. So the object model inside the application code, if it also is faithful, then your faithful data model and your faithful code model are more likely to closely correspond. And that's going to reduce the impedance match that is run into between object models and data models when you're building object-oriented applications. Even more important, you capture scale throughout the application. So small to small, large to large, huge to huge. You get this correspondence because you have a faithful and accurate copy or reproduction of the real world. You see this in the data volume, hence why a normalized model reduces the data volume and reduces data redundancy. You see it in the complexity. Something that's not very complex in the real world becomes not very complex in your models. That's where you get your simplified updates. You see it in the change scope. So you minimize surprises when a new business requirement comes along, such as, oh, and we want to run this in 2016 as well as in 2015. You don't get any surprises of, oh, and that's 10 weeks work. It's an hour's work like it should be. And programming effort as a reflection of real-world activity. So when you actually get a fairly small occurrence in the real world, it becomes a small programming effort. So again, fewer surprises. You gain stability, because when the model is faithful, then it's not going to vary through the lifetime of the application. Business requirements change slowly, whether they're due to GAAP in an accounting database, or the Income Tax Act, or the Provincial or Harmonized Sales Tax Acts. These changes occur slowly, they tend to be small, and when your model is faithful, you get the same sort of stability. Additionally, through the actual development cycle, errors in the original specification are usually small. So you get a small error and a small correction. You have a big error, well, okay, now we might need a big correction. But as soon as you realize it was a big error, you knew that right away. So there's no surprise there. And the fewer surprises reduces your risk. So when you take your data model and you normalize it, you get a faithful model, the whole risk through the development cycle and the life cycle of the product itself is reduced. So, why does this matter? Well, by thinking about the database normalization in this way, you're tying all the bits and pieces together. Rather than just having a laundry list of the items you remember today, you have a more comprehensive framework that allows you to figure out whether there's truly any validity in an argument for denormalization, because you have a better framework to model it in. So denormalization confounds the scale assumption, because it's always a case of, well, we're going to make this one little piece more performant by making an invalid assumption on the business rules at the potential expense of everything else. So once you realize that because you're sacrificing potentially everything else, you really have to tackle the scale assumption and say, well, since we can't assume with this invalid assumption that our scale assumption is accurate, now you can force the burden of the proof onto the person who's suggesting the denormalization to say, well then, prove that the scale assumption still holds in the parts of the model you're invalidating. Or list it as a project risk on your denormalization suggestion. So, normalization is traditionally justified with a laundry list of benefits. I think that's a bad way to think about it. I think you really need to look at it as, by normalizing your data model, you're making it higher fidelity, more faithful. And that gives us better structure for truly measuring any trade-offs that are proposed through a denormalization process. So hopefully that helped a few of you who may be looking at we're working. Yes, question?
Wouldn't this help with performance of the database as well, normalization?
It can, in a number of ways. The reduction in the data volume will typically also reduce index height, and so your searches, so more of the index, a higher proportion of the index is sitting in the cache. It is a memory access rather than disk access. The reduction in data volume through the elimination of redundancy also means your index height is slower. So yes, normally, the trade-off though is you increase the number of joins. And that's where the argument is often made that a denormalized structure will be better. Because you're reducing the joins. My point is really it should be up to the person proposing a denormalization to actually prove there's a problem with the current performance and that their performance will be better and it's not going to have a big enough impact. Because really what you're doing is you're saying this little piece is really important and I'm going to try to make that faster. And I'm going to sacrifice everything else, but those sacrifices won't add up to a big enough number. Well, you really should say, well, then prove it. Right? But as I say, specific instances, a data warehouse, by definition, is completely denormalized. But if you have a moderately normalized transactional database, which has perhaps become denormalized over the history of the application and changes were made, and then you want to scrub your data and then put it into a data warehouse, one of the best ways you can scrub your data is to push it through a fully normalized design. Because there are all sorts of potential errors in data that simply structurally can't exist in a normalized database. So when the data fails to load into the intermediate stage, you go, oh, okay, we got to fix the data. And then you push it into the data warehouse, where you have all your flattened tables that build your pivot reports.
I have a question. So, historically speaking, with the database evolution, normalization wasn't like a common sense approach to eliminate duplication, things like that. Don't you think so?
That's the tension between the application developers and the database developers and database administrators. On the database side, it has always been felt since the mathematics was worked out by Boyce, Codd, Dave, McCarthy in the 60s, was always felt that normalization was right. But the database developers were not always in charge of building the data models. And application developers have different ideas sometimes. I sort of sit straddling the fence because I'm an application developer, but I see things the database administrator way. So I'm a bit of an exception, and it probably comes from my math and physics background originally. But yeah, there's lots of databases where it was just felt unnecessary to normalize. I think people are learning that they run into the problem when they go to scrub the data. They're collecting from all these sources. Scrubbing the data becomes painful. And they're learning that one of the best ways to scrub it is just push it through a normalized database. But yeah, there was this tension where it wasn't always felt.
From the theory point of view, when the relational database theory was developed, for them it felt like naturally to normalize, with those 5 forms of normalization. Yeah.
Right. And I was in that camp, so it always felt natural and commonsensical for me. But I understand that other developers with a different background did not see the same reasons. Part of this is my argument as to why I'm right. Any other questions? Or do you agree to?
Thank you.